Hello guys, and welcome back to Mind Blowing Math. So we are now talking about the division theorem. So let's begin by reminding ourselves of some terminology about numbers. So for example, integers. So we've got -2, -1, 0, 1, 2, 3, and so on. And the positive integers, or we call the natural numbers, are 1, 2, 3, 4, 5, 6, and so on. So it can be useful to represent the integers by equally spaced points on a straight line. For example, like this. So this straight line is known as the number line. So there are other points on the number line that don't correspond to integers, such as 1/2 square root of 3 or pi. But in this unit, we'll focus most of our attention on integers. 0, 1, 2, 3, 4, and so on. -1, -2, -3, -4, and so on. So an integer a is said to be divisible by a positive integer n if there is a third integer k, if there is a third integer k such that a equals to n times k. So we also say that a is a multiple of n, and n is a factor, or we may call it as a divisor, of a. For example, 84 is a multiple of 12. Also, 84 is also divisible by 12. So 12 is a factor or divisor of 84. Now, let us consider the integers 38 and 5. So clearly, 38 is not a multiple of 5. In fact, 7 times 5 is smaller than 38, which is smaller than 8 times 5. So we have trapped, which we can also write it as 7 is smaller than 38 by 5 and 38 by 5 is smaller than 8. So we have trapped 38 by 5 between two consecutive integers 7 and 8. The integer 7 is on the left is known as the quotient on dividing 38 by 5. Now, since 7 times 5 equals to 35, we can see that 38 is 3 more than a multiple of 5. So the number 3 is known as the remainder on dividing 38 by 5. We can write 38 equals to 7 times 5 plus 3. So we call 7 as the quotient and 3 as the remainder. So you can obtain a quotient and remainder in this way whenever you divide one positive integer a by another positive integer n. So the remainder is 0 if a is divisible by n. So the remainder is 0 if a is divisible by n. So now let's suppose a is negative. For example, you wish to divide negative 38 by 5. So you can trap negative 38 by 5 between two consecutive integers as follows. Negative 8 is smaller than negative 38 by 5, which is smaller than negative 7. So once again, the quotient is the integer on the left, namely negative 8. The remainder is then the difference between negative 8 times 5, which is equal to negative 40, and negative 38, namely 2. So you can write negative 38 equals to negative 8 times 5 plus 2. So negative 8 is the quotient, while 2 is the remainder. So this time, the quotient is negative, but it is chosen so that the remainder is still positive. The reason why we chose the quotient in this way to give a positive remainder is because this choice simplifies Euclid's algorithm, which you'll meet in the next subsection. So these observations about division can be summarized in the division theorem, sometimes known as the division algorithm, stated below. So suppose that a is an integer and n is a positive integer. Then there are unique integers q and r such that a equals to qn plus r and 0 is smaller or equal to the remainder, and the remainder is smaller than n. So this is what we call the division theorem. So I hope you enjoyed this video, and the PDF for the problem list is shown below. So I hope you have a great day, and bye.